Okay, what happens? A light ray strikes on a shiny surface. You learned that in the lessons of reflection. So this light ray starts to reflect according to the law of angle of incidence equals to the angle of reflection. Okay, so that's what happens, reflection. But what happens here when a light ray strikes on a transparent object? So this is the normal drawn to the surface, intersurface at the point of incidence. Now, what would happen, Buddha? This light ray starts to not reflect, it starts to refract. It changes its direction. Okay. So I'll draw that somewhat clearly. As this is a lens, it's not clear because these lenses are working according to the concept of refraction. So this is a medium glass. Okay. So this is the medium air. So both are transparent mediums. So this is the intersurface between two transparent mediums. Now a light ray is coming towards the glass from the medium air. So it travels from one transparent medium to another transparent medium. Now, initial direction of this light ray is like this. What do you think? Will it go through the same path or
It will go on a different path.
yes, definitely it's changed its direction. So this ray is known as the incident ray. This is known as the incident ray. Okay. And the angle is known as the angle of incidence. Angle of incidence. Incidence. Angle of incidence. So this is the angle of refraction. But if it happens through the same medium, air to air, so this will happen. Air to air. No change in the direction, but this is glass. Somewhat denser than the medium air because these glass particles are tightly compacted. Okay, then the speed of the light decreases when it moves from air to glass. Okay, so what happens? It comes like this, and due to the low speed of the light in the medium glass, it changes its direction. Okay, so what happens actually? It bends towards the normal. It bends towards the normal. So if both mediums are air, no change in the direction, but because of this glass medium, initial direction change actually towards the normal drawn to the intersurface at the point of incidence. පුතා මේ ලයිට් රේක ස්ට්‍රයික් වෙන තැනට the point of incidence කියලා අපි කියනවා. Where the light ray strikes on the surface, that point is known as point of incidence. So this is the point of incidence. And light ray, its initial direction is changing. So this is the initial direction, and light ray change its direction. So this changing of the direction of a light ray, what? Changing of what? Changing the direction of a light ray. Simply changing the direction of a light ray when it travels from one transparent medium to another transparent medium. Okay. So this is not in our syllabus, but you have to know this. So what does it mean by refraction? Okay, so what does it mean by the refraction? I think now you have understood this. Change in the direction of a light ray, but there's a condition. Refraction කියන්නේ ආලෝක කිරණයක දිශාව වෙනස් වීම. Change in the direction of a light ray. But you have to specify when it happens. So you have to tell when it travels from one transparent medium to another transparent medium. Now tell me the complete answer for the refraction or complete definition for the refraction. Changing of the direction of a light ray when it travels from one transparent medium to another transparent medium. Changing of the direction of a light ray when it travels from one transparent medium to another transparent medium. Okay, so Tisanya, leave and come. Uh, I like to talk to Sarah. Sarah, so this definition is you have to keep in your mind, but it will never appear in your exam. ඉක්මනටම කියමු අපි time waste නොකර. So what does it mean by refraction?
Changing of the direction of a light ray
Yes.
travels from no travels uh,
When it travels from one transparent medium to another
another
transparent medium.
transparent
Okay, so
medium.
that happens in transparent mediums. Thank you. ඒ දැනුම තිබ්බහම ඇති. So that's enough for you. Now, what I wanted you to explain is the phenomena that happens in a lens. So lens is made up of transparent material. When a light ray comes from one transparent medium to another transparent medium, the same refraction process happens here. But you have learned a parallel beam of light when it exposed to a convex lens, this parallel beam of light, what happens? Okay, they converge to a single point. What's that single point? That single point is known as the focus. Okay, one by one. So let's take down all these things. Okay, let's write function of the eye lens. Before that takedown, there are two types of lenses. There are two types of lenses. First one, convex lens. The other one takedown, concave lens. Convex lens and concave lens. There are two types of lenses. One is convex, while the other one is concave lens. Okay. Next point, take down. Convex lenses converge light rays. Convex lenses converge light rays after the refraction. Convex lenses converge light rays after the refraction into into a point into a point called focal point. Focal point. Focal point. Okay. Next, take down concave lenses. Concave lenses diverge. Diverge. Diverg. Concave lenses diverge light rays. Okay, now we are going to demonstrate both actions of convex lens and concave lenses. Both of lenses are exposed to parallel beam of light. Okay, parallel beam of light. What's the function of this convex lens? It converges these light rays into a single point. Okay, single point. We call that the focus. We call it the focus. Focus. And the length between the focus and the plane of the mirror. So we call that focal length. That length is focal length. Focal length. Okay, I'll demonstrate that. So that's focal length. Here's the focus and focal length. Okay, simply take it down. Here's the convex lens, and this is the concave lens. Next, we are going to study the function of the concave lens. Okay, let's take a parallel beam of light. Parallel beam of light. Okay, this concave lens, it diverges these light rays as they are coming from a point. As they are coming from a point in front of the lens. එයාගේ focus එක තියෙන්නේ කලින්. Okay, so this focal point F, so that's in front of this. Okay, so before the refraction, they refract as they are coming from the focus here. මෙන්න මේ focus එකේ ඉඳන් ආවා වගේ. Okay, so that's actually not happening, but it refracts like this. So this is not actually happening. Therefore, we draw it with broken lines. Okay, so you have to use the same ruler. And here, look at this. from the focus to the point, the broken line, and we have to continue the same. මේක පුතා ඇද වෙන්න අඳින්න එපා. මෙතෙන්ට ඉඳන් ඇවිල්ලා මේ ටික මෙහෙම අඳින්නේ. නැත්තම් මෙහෙම අඳින්නේ. හරි? So you have to use the same direction as these broken lines are like this. Okay, so this is the way. And focus පුතා මේ optical center හරියටම lens එක මැදට ආපු light ray එක refract වෙන්නේ නැහැ කෙලින්ම යනවා. So we haven't drawn such a light ray in convex lens. Okay, I'll draw it like this. හරියටම optical center එකට ආවොත් it will never refract. It goes like this, directly යනවා. Because if you consider this middle of the lens, it's just like a little glass. Look at this. පුතා මේ මැද කොටස සලකන්න. Okay, consider this middle of the lens. අපි මේ අනිත් ඒවා අමතක කරලා දාමු. It is not actually a convex or concave. It's just a glass. Therefore, the light ray comes perpendicularly to that, never refract. It goes straight on a straight line. Okay, so that's the same thing happens here. It never refract and goes through the lens. Here also the same thing you have to apply. As it is coming from the focus, it diverges. Okay, so this is the way of refraction through concave lens. Convex lens, converge light rays. Concave lens, diverge light rays. I think you could understand this clearly. The action of convex lens and action of concave lens. පුතාලා මට ඔගොල්ලෝ මේක ඇඳගෙන ඉවර නම් මට finish කියන්න F කියලා message එකක් එවන්න. Good. 2 students have completed this. Okay, that's enough. හරි. පුතාලා මේක ලියාගෙනයි තියෙන්නේ. So convex lens and concave lens. Next point, take down. Out of about 2 types of lenses, eye lens is a concave lens. A concave. Sorry. Convex. I'm terribly sorry, okay? ඇත්තටම කියනවා නම් මේ වැරදුනා නෙමෙයි. සිහියෙන් දින්න කියලා බැලුවේ. Okay? Eye lens is a convex lens. Rama, so can you tell it again? Okay. Out of about 2 types of lenses, eye lens is a convex lens. There are 2 types of convex lenses. Okay. Here, both sides are convex. Therefore, we call that biconcave. Biconcave. Sometimes one side is plane, only one side is convex. Okay, so that's plane convex, So this is biconvex, and sometimes in concave lenses, you can observe these types of biconcave as well as only one side is concave. So these things come across in eye defects as solutions of wearing spectacles. So we come across them. Okay, let's discuss them later. So eye lens is a convex lens. Next, take down its curvature. Its curvature is controlled. Its curvature is controlled by the ciliary muscles. Okay, so this is ciliary body. You can observe ciliary muscles as you learned last week. So this is cornea. But in the process of focusing the image of the object in front of the eye on the retina, okay, so that's on the retina. This is the outer layer of the eye. No need to draw all these things. Okay, so this is optical nerve, blind spot, yellow spot, or fovea. So this is the typical structure of the eye. But in this lesson, we draw only the eye lens and this eyeball. පුතා අපි මේ cornea එක අඳින්නෙත් නැහැ. So what we need to study is the action of the eye lens. Okay, next point take down. When a closer object is observed by the eye, when a closer object is observed. Okay, look at this. This is the eyeball. As I mentioned you earlier, we show only eye lens and eyeball. So this is eye lens. When the eye observe objects which are situated far away, those light rays are coming as a parallel light ray. When light rays are coming from an object situated far away, so this eye feels it like from light rays from infinity. අනන්තයේ සිට ඉන්ෆිනිටි වල ඉඳලා ලයිට් රේස් එනවා වගේ තමයි ඇහැට දැනෙන්නේ. මේක හුඟක් අයට තේරෙන්නේ නැහැ. තෝරන්නත් අමාරුයි. Right? I think you can understand this. Definitely I'll teach you that part. මට ඔක්කොටම කලින් කියන්න පුතාලා. What do you think? Can you understand? So when a light rays coming from far away, I feels these light rays are parallel. මොකද්ද මේ අනන්තය? What's this infinity? ඔය කියන infinity කිලෝමීටර් 10 ගාණක් ඈත තියෙන infinity නෙමෙයි. අනන්තය නෙමෙයි. That's 1 or 2 meter away from the eye. ඇහැට වඩා මීටරයක් දෙකක් ඈත නම් ඇහැට දැනෙන්නේ infinity කියලා තමයි. If the object is situated 1 or 2 meters away from the eye feels like it is an object situated at the infinity. What do you think? තේරෙනවද? මට message කරන්න. Tell it again. හරි. English හොඳටම තේරුණා කියම ගොන්න මම පැහැදිලි කරන්න. When an object is situated 1 meter, okay, 2 meter ළඟනේ, so that's closer. 1 meter, 2 meter means very close. But I feels like these objects are situated. These objects are situated. මේ ළමයෙක් ඉන්නවා හිටගෙන හරි. නැත්තම් candle එකක් ගමු අපි. අපි සාමාන්‍ය experimental usually we take candles for the experiments. Candles, a light source. I feels ඇහැට දැනෙනවා. These light rays are coming from the infinity. Parallel වගේ තමයි යාට එනවා දැනෙන්නේ. But actually the objects, if they are closer to the eye, they must come like this angular way. Angle එකකින් එන්න ඕන ඇහැට. හැබැයි ඇහැට පේන්නේ I feels like these light rays are coming parallel. Shannon can understand. තේරෙනවා sir, ඒත් එහෙම තේරෙන්නේ නෑනේ. මට අන්න එකයි ඕනේ. හුඟක් අයට තේරෙන්නේ. Because I can make you understood. මට ඔයාලට තේරුම් කරන්න පුළුවන්. ඔක්කොටම කලින් මම දැනගන්න ඕනේ තේරෙලා නැද්ද කියලා. හරි? ඒකේ වටිනාකම කියලා දෙන්නත් ඕනේ. Okay, let's see that. එහෙනම් හැමෝම ලෑස්ති වෙන්න තේරුම් ගන්න. පුතා, when the eye is at the normal state, when we are observing objects situated far away, okay, ciliary muscles are relaxed. Ciliary muscles are relaxed. So eye lens becomes, its curvature becomes normal. Okay, so less curvatured, the original state, ciliary muscles are relaxed. So we can observe light rays from the objects situated at the infinity. The only thing you have to know, this infinity is not several kilometers away, that just 1 or 2 meters. Then this eye lens can easily focus that light rays to the retina. පුතේ ඔන්න retina එකට focus කරගත්තා. Here's the retina where the light sensitive cells are existing. Retina. Okay. So this is light rays from faraway objects. අපි candle එකක් මාදිමු. Usually we take the plane. Okay, so I'll draw the plane. So image is created on this retina. So this is what actually happens. When observing objects far away, curvature of the islands is lesser. Okay, but when you observe objects closer, these islands curvature is increased. Then ciliary muscles have to work hard. අපි ඒක ඊළඟ diagram එක අඳිමු. Now, when a closer object is observed, before that you write when the eye is in the normal state. Okay, take down. When the eye is in the normal state.
Sir,
පුතා කියන්න.
you didn't complete the last sentence. When a closer object is observed by the eye.
When the closer object is observed by the eye, uh, I think I have told you the topic. මම mean පටන් ගත්ත දේ වගේ sentence එකක් කියන්න ඔයගොල්ලන්ට. Did I commence a sentence and uncompleted? Okay, complete it. When
Okay, sir.
closer object is observed by the eye, curvature of the eyelids, curvature of the eyelids, curvature of the eyelids has to be increased, has to be increased. Curvature of the eyelids has to be increased to focus it on to the retina. Focus it on to the retina. Okay, but now continue. But in the normal state, of the islands, normal state of the islands, when observing objects situated far away, far away, far away, ciliary muscles are relaxed, ciliary muscles are relaxed, ciliary muscles are relaxed, and the curvature of the eye is decreased. Curvature of the eye is decreased. Okay, so this is normal state. පුතා ඇහැට හුඟක් ඈතයි කියන්නේ far object කියන්නේ මොකක්ද? So when this object is 25 centimeters, okay, 25 centimeters means close. Clear image can be seen when the object is 25 centimeters away. ඔගොල්ලන්ගේ ඇඟිලි වල රේඛා පේන දුර ගන්න. So the lines on your palms can be clearly observed at the distance of 25 centimeters. So that's the distance where we can obtain a clear image of the object. So that's 25 meters of distance. If you observe something uh, at a very closer level more than that, you feel somewhat hard. It's painful. තව ළඟට ගත්තොත් ඇස් රිදෙනවා. Okay, so that what usually happens when you closely look at on your mobile phones also. Because when we observe that closer objects, this curvature of the islands increases. මේ diagram එක පුතාලා ඉක්මනට ඇඳ ගන්න. I think you have already drawn that. Title: Normal state within bracket far object. Okay, so this distance may be 1 meter, 2 meter of distance. Okay, next let's take down what happens when we observe a closer object. Then තමයි topic එකට අදාළ diagram එක අඳින්න යන්නේ. So this is the normal state. May I erase this? I think you have drawn that. Okay, now the object is here. Let's take a point object O. Now, if you are trying to focus this with this curvature, පුතා දැන් මේ curvature එකෙන් focus කරන්න ගියොත් වෙන දේ. You know that parallel light ray focus to the retina correctly. You knew that. Without changing the curvature, what happens we are going to observe a closer object? Same curvature, we don't allow these ciliary muscles to increase or decrease the size of these islands, curvature of the islands, same curvature. Assume like that. Curvature is same, but we take the object closer. Now, the new light ray is like this. පුතා අලුත් light ray එක මේ වගේ. So it is angular. It just like you take down this initial light ray down. හරියට කලින් light ray එක පාත් කළා වගේ. What would happen if this light ray get down like this? So this refracted light ray goes up. Refracted light ray goes up. හිතන්න පුතාලා curvature එක වෙනස් කරන්නේ නැහැ. Islands එක එයා වැඩ කරන්නේ නැහැ හරියට curvature එක වෙනස් වෙන්නේ නැහැ. Curvature is not changing because of the action of these ciliary muscles. අපි chemical එකක් දාලා we are applying a chemical to stop the function of these ciliary muscles. Now the eye is not working as usual. It cannot focus. Imagine what happens. This light rays coming from a closer object. It angularly comes. It comes angularly. Angular means another in slanted light ray. When this light ray comes like this, actually what happens, it refracts like this. The image is made. The image is made away from the retina. පුතා retina එකට ඈතින් තමයි image එක. So in this case we can observe a blurred image. අපිට පේන්නේ blurred image එකක්. අපි මේක එක්ස්පීරියන්ස් කරමුද? Okay, let's see that. අපිට ඇහැ තියෙනවා, objects උත් ඕන තරම් තියෙනවා, blurred image එකක් ඇති වෙනවද බලමු. හැබැයි අපිට ciliary muscles action නවත්තන්න බෑ. We cannot stop the action of ciliary muscles. අපි යාගේ limit එකට වඩා ලං කරමු. Okay, now take your hand like this. Okay, now at 25 centimeters you can clearly observe the image of the palm. Can you do that? Niluka, what about you? Can you observe that? Okay, now little by little close your palm towards the eye. At a certain level, image becomes blurred. Image becomes blurred. Did you observe it? හරි. දැන් ඕක ළඟට ගන්න එපා, ඔළුව කද්දී හැදෙයි. හරි. Okay. Now it becomes blurred. බලන්න blurred වුණා දැක්ක අය B කියලා message කරන්න මට. B blurred. Okay. Shenal okay. Nadika okay. Good. That's enough. Now look at the board. Putha, blurred means this object is here. Sharp image cannot be created because image has been created beyond the retina. Beyond the retina. That's the reason. හැබැයි පුතා මෙහෙම වෙන්න දෙන්නේ නැහැ. අපිට බෑනේ මේ retina එක මෙතනට ගේන්න. We cannot change the length of the eyeball like this. Eyeball එක අරන් යන්න බෑ. When you are focusing image to a screen by using a projector, you can change. So you can change the direction and the distance from projector to the screen. Screen එක අරන් යන්න පුළුවන්. So you can focus that. But you cannot change the distance of the eyeball. Instead, what your eye does, ඇහැ මොකද කරන්නේ? එයා curvature එක වෙනස් කරනවා. It change its curvature like this. It change its curvature and focus this light ray directly onto the retina. තේරුණාද පුතාලට වෙන වැඩි? මේ retina එකෙන් පිටිපස්සේ image එක ඇති වෙන හින්දා, so that is sensed by the brain. Optical nerve is goes to the brain directly. Then brain can understand image is blurred. Image is blurred. It gives a message to ciliary muscles. මෙන්න මෙහෙම කියනවා. bossනේ, brain is the boss and he is telling, hey ciliary muscles, what are you doing? The image is blurred. Please work hard and increase the curvature of the eyelids as I can clearly see the image. කියලා brain එක කියනවා මේ මොකද ciliary muscles ඔයා කරන්නේ? ඕක ඇදලා හොඳට අල්ලන්න, curvature එක වැඩි වෙන්න. එතකොට මොකද වෙන්නේ? Clear image can be created on the retina. Sometimes these types of things happens. What? Curvature is too much of curvature. Now what would happen? Image occurs before the retina. Retina එකට කලින් හැදෙනවා. Now also image is not clear. In that case, ciliary muscles start to relax as the eyelid's normal curvature is made. Okay. So normal state already we learnt. Now the real diagram when the object is closer. I think you had better to draw the ciliary muscles also. This is ciliary body and ciliary muscles, retina, curvature of the islands has been increased. Okay, so then closer objects can be clearly seen. Okay, closer objects can be clearly seen as the island's curvature is increased. Okay, now take down this. Curvature of the islands has been increased. Curvature of the islands has been increased when closer objects are observed. Shannon, පුතා ඔයාගේ mic එක on වෙලා. Thank you. Dulkit, can you understand what happens here?
Yes, sir.
Okay, so what happens when closer objects are observed?
The curvature of the lenses has been increased.
Curvature of the eye lens is to be increased. Here it has been increased. Okay, what happens when an object situated far away is observed? Ciliary muscles relax. The eye lens come to the original curvature. That means less curvatured. Okay, I want to talk to Shenal.
Yes, sir.
Buddha, so what helps to these eye lens to increase its curvature?
The ciliary muscles.
Ciliary muscles. So how it is increased? That means how curvature is increased. I mean by the contraction of the ciliary muscles or relaxing?
Contraction.
By the contraction. ඇත්තටම මම මුලින් පොඩි කාලේ හිතන් හිටියා මේ විදිහට අදිනවා කියලා. නමුත් ඇත්තටම කරන්න මෙයා දෙපැත්තෙන් අදිනවා. Okay, so if I show you the 3D diagram of that, it's look like this. This is ciliary body. It's already attached to, so this is what hold the islands. Okay, it exists like this. So ciliary muscles come from the ciliary body and it is connected to islands like that. මෙයා වටේටම තියෙනවා. It exists as a circular way like this. Yes, the eye lens, front view. So ciliary muscle layer is like this. One side. So what it does, attract. Okay. So it fold this. As a result of this, eye lens curvature is increased. Its curvature is increased. The usual or typical curvature is like this because of the action of these ciliary muscles. Its curvature is increases like this. I think you can understand it. Good. Okay, why do we learn these things? So we are going to study the defects of the eye. Defects of the eye. To study the defects of the eye, we have to know this focusing process of the eye lens. Okay, now take down the topic, eye defects. Eye defects. Okay, now take down. There are two types of eye defects. There are two types of eye defects. First one, long sightedness. Long sightedness. In your book, it has been given as long sight. We call it hypermetropia. 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 Long sightedness. Second one, short sightedness. Myopia. Short sightedness. Myopia. Myo means muscles. Myo means muscles, Latin term. Myo intends muscles. So we can guess this disease is, this defect is due to a weakness of a certain muscle. Okay, let's discuss them later. Long sightedness and short sightedness. Okay, subtopic take down, long sightedness. පුතේ අපි දැන් ඉගෙන ගන්න යන්නේ මේ long sightedness කියන එක. The real meaning of that is the ability to observe objects far away. Meaning of the long sightedness or long sight means ඈත පේනවා. ඉතින් ලෙඩක්ද? එහෙමත් හිතෙනවා නේ. අපිට කියන්න තිබ්බනේ ඈත පේනවා නෙමෙයි මෙයාගේ ලෙඩේ. Long sighted means actual problem is these patients cannot observe close objects. Long sightedness දුර පෙනීම. එවනට නොහැකියාව ළඟ නොපෙනීම. I think you can understand. Name of the defect is long sightedness. That means ability to observe objects far away. So actual defect is, so what the situation is, closer objects cannot be observed. Okay, take down. Nature of this defect is, nature of this defect is, nature of this defect is inability of, inability of, inability of observing, inability of observing closer objects, closer objects. දැන් පුදුම වැඩක් තමයි. දැන් ලෙඩේ තියෙන්නේ ළඟ පේන්නේ නැති එක. ඇයි? What's the reason not to name it as inability of observing close objects? ඇයි එහෙම නමක් දැම්මේ නැත්තේ? Blindness වගේ, short blindness. එහෙනම් මේකේ මොකක් හරි දෙයක් ඇති නේද? Yes. So this name is actually for the betterment of you, to better understanding of you. By using this name, we can identify what happens actually here. මේ නම පාවිච්චි කරලා තමයි පුතා ray diagram එක අඳින්නේ. මම මේක කියලා දෙන්න. හුඟක් අය ඒක දන්නේ නැහැ. 90% of students and teachers don't know how to draw this by using the name. අපේ පහසුවටයි මේ නම මේ විදිහට තියලා තියෙන්නේ. Long sightedness. Shenal, what do you think about this name of the defect? It's controversial, no?
Yes.
It's confusing. Why it is? The ability is capability of observing objects far away, but inability is observing
Same.
the objects in
Closer.
closer. But it has been named as long-sightedness.
Long-sightedness.
Okay. Let's understand the situation there. Okay, now I am going to draw the associated ray diagram. එහෙනම් පුතාලා ඔක්කොම ඔයගොල්ලන්ගේ pencils, pens පැත්තකින් තියන්න. Okay, now look at the board for the clear understanding of this. Long-sightedness means he can observe objects situated far away. That means light ray that is coming from far away objects, so they are parallel. They are parallel. If it is parallel, eye lens is normal curvatured. Okay, that's normal curvatured one. So long-sightedness means objects far away can be clearly observed because it is clearly focused onto the retina. No problem with that. මෙයා චුට්ටක් ඇදයි වගේ මම මෙතනට focus කරන්න. Okay, and here. Now image is formed. No problem with that. This is a normal situation. This is not the defect. Then what's the defect? Defect is inability of observing closer objects. So as this is not the defect, Puta, I'll make that broken line. I'll make it a broken line. Now I keep the closer object here. Closer object. Now look at this. Actually, light rays coming from the closer object. අපි මෙතනටම ඇඳ ගන්නවා. Compare කරන්න. We draw this incident ray to the same point just to compare. Then we can make a logic. If this parallel light ray is come down like this, ඒක හරියට මෙයාව පාත් කළා වගේනේ. Then what happens to this refracted ray? It goes up. මෙයා මේ පැත්තෙන් පාත් කරද්දි මෙයා ඉස්සෙනවා. So if we uh, pull down this is rising up. Okay. As a result of this, focusing occurs away from the retina. Focusing occurs away from the retina. Yeah. So this is the defect, and the same thing happens here. Okay. This is what happening. Who can understand the way of drawing the ray diagram? පුතා ළඟ තියෙනේවා blurred වෙන්නේ මේ හින්දා. Yes, by using the name long-sightedness, we make two parallel lines as they are coming from far away from the infinity. Okay, so we can clearly draw that. Keeping it as the template, our template එක විදිහට තියාගෙන, keeping it as the block, now we are going to assume what happens to the light ray that is coming from an object situated closer to the eye. Who can understand this? තේරුණු අය 1 කියලා message කරන්න. පුතා දැන් මේ diagram එක පාඩම් කරන්න ඕනේ. Logic is in your mind. If you know the name of the defect, you can draw it. You can draw the ray diagram. ඊළඟට මම කියලා දෙන්නේ මේකට solution එක. How to take the solution for this defect. දැනට පුතාලා defect එක ඇඳගන්න. Long-sightedness defect. Now draw this ray diagram. This is the most accurate and clear way of drawing the ray diagram for the defect long-sightedness. Closer objects cannot be observed. තේරෙන්නේ නැති කෙනෙක් ඉන්නවනම් 0 කියලා මැසේජ් කරන්න. One messages ආවේ බොහොම සුළු ප්‍රමාණයක්. I think they are drawing. Shinal Rodrigo. Okay, I'll explain to you, Buddha. Now, just draw this. No, Nelly, just you have to draw this. After drawing this diagram, පුතාලා මේ diagram එක තේරෙන්නේ නැතුව අඳින්නත් ටිකක් අමාරුයි. Sir, is this happened because of problem in the ciliary muscles? Nadika, two things. හේතු දෙකක් තියෙනවා. I'll explain. Good question. Now stop. මකන්නේ නැහැ මම. අඳින එක නවත්තන්න. Now I am going to explain it again. පළවෙනි කාරණේ, the first thing, this is much difficult. First I learned this in A level. Next it was in grade 11 syllabus and not this much. Okay. In grade 9, You have to learn the things that was in grade 12. Okay. All theory නැත්තේ. I think the first part is okay. Long-sightedness means the light rays that are coming from far away. Parallel light එකක් આવොත් එයා හරියටම focus වෙනවා. So that's long-sightedness. දුර පේනවනේ. හරි? දුර පේන්නේ හොමයි. දුර පේන විදිය පැහැදිලි අය. If you can understand how this person or the patient can observe the object far away. Okay, ඒක තේරෙන අය මට ඕකේ කියලා මෙසේජ් එකක් දාන්න. ඈත ඒවා පේනවා. මේ broken line is okay to you. Now problem is ඉතින් සර් කොහොමද මේ ළඟ ඉඳන් එන light rays ඔයා ඇයි ඒක එතනටම ඇන්දේ? ඇයි ඒක එතනටම ඇන්දේ මේ? ඇයි අඳින්නේ මේ? What's the reason behind that? So such a question may be in your mind. So we want to compare. We know this parallel light ray already focused to the retina. It's okay. We know that. But we don't know how this light rays that is coming from the closer object refract. ඒගෙන දැනුමක් අපිට නැහැ. So we have to make a logic. In that case, we have to make a logic. තර්කයක් කරන්න තියෙන්නේ. We have to compare. How to compare? We compare like this. If this closer light ray is the earlier light ray, pull down. මෙයා හරියට කලින් ආපු light ray එකම මේ විදිහට පාත් කළා වගේ. Just like turning down. මෙයා turn down කළොත් එයත් එක්කම හිටපු අනිත් එක්කෙනා proportionally it goes up. So that's the logic. ඒ තමයි logic එක. If you pull this down up to this level, so this clearly focused light ray also moving up. Okay, so they are interconnected. Okay, because of this eye lens, according to the refractive index of these eye lens, the same thing happens. So according to the value of this angle of the incidence, angle of refraction depends. Okay, now can you understand the theory? Can you understand the logic? දැන් මොකද කියන්නේ ෂෙනාල්? So that's the logic. Can you understand? Further explanation
Yes.
is required?
No.
Good. තව අපේ තිසන්යා, what about now? තිසන්යාට තේරෙනවද? Okay, good. දැන් මෙතන හුඟක් students ලා ඉන්නවනේ. මට ඇත්තටම so your honest answer must be here. Can you understand clearly? Clearly understand it or not? CR clearly understand. So CR කියලා මට message එකක් දාන්න. නැත්තම් 0. නැත්තම් no හරි 0 හරි දාන්න. 1 2 3 4 5 6 7 8 9 10 11. Okay, good. හරි. පුතාලා එහෙනම් complete කරගන්න diagram එක. දැන් මේ ඇඳලා ඇති අමුතු එව්ව සමහරු මෙතනට ඇඳලා නැතු ඇති මේක. එහෙම ඒවා වෙනවා. තේරෙන්නේ නැතුව ඇඳපුවම අමුතු එව්ව අඳිනවා. Okay. Okay, good. එහෙනම් මම solution එක දැන් කියලා දෙන්නයි යන්නේ. Now you know the defect. Okay, let's study the solution. This is the defect, and now take down solution for the long-sightedness hypermetropia. පුතා මේ මම දන්නේ නැහැ මේ හුඟක් අය මේක උගන්වනවාද කියලා. ඔයගොල්ලෝ එක්ස්පෙරිමන්ට් එකක් කරලා බලන්න විවිධ ඔන්ලයින් ක්ලාසස් ෆිසිකල් ක්ලාසස් වලට තියෙනවා නම් මේක මේ මට්ටමට ගැඹුරින් ඉගැන්වෙන්නේ නැහැ. මටත් මේක හරි ලේසි ඔයාලට කටපාඩම් කරලා නිකන් ඉන්න. So I can tell you a way how to cram this, but you have to study this logically. That logic is very important. Okay, now you know the problem. So this is the eye lens. It try to focus the object by increasing its curvature, but it is too much. Ciliary muscles cannot increase the curvature to focus it onto the retina. මොකද උනේ පුතේ ඉතින්? The light rays that are coming from a closer object, it came like this. හරියටම focus එකට ආවද පුතා? Shenal, what happens? Onto the retina or beyond the retina? What happened?
Beyond the retina.
Beyond the retina. So we have to draw that. So this is the defect. This is the defect. But this is not the main diagram. Now we are going to draw the solution associated ray diagram. Solution associated ray diagram. ඉතින් එහෙනම් this is broken. This is the defect. Another ray set is coming for the solution. Puta, now what we have to do? Converge this. මෙයා තව එකතු කරන්න දෝනේ, converge කරන්න දෝනේ, diverge කරන්න. What we have to do? Converging or diverging?
Convert.
Yes, we have to converge this. Focus එකට ගන්න converge කරන්න. So what is the type of converging lens? Converge.
Convex.
Yes, that's
Convex
convex.
lens.
Definitely we have to use a convex lens. එහෙනම් පුතා convex lens එකක් තමයි දාන්න වෙන්නේ. We have to use a convex lens. ඉතින් මම මෙන්න මේ වගේ convex lens එකක් අර සාමාන්‍ය convex lens එකක් නෙමෙයි මෙහෙම තියෙන්නේ. ඔයගොල්ලෝ බලන්න අම්මා අප්පච්චි ගාව තියෙනවා නම් if you have that convex lens in spectacle, it looks like this. It looks like this. Both side curvatured. I'll use the black color. Okay. This is the spectacle lens. We decide that it must be a convex one because it has to be converged. හරි. එහෙනම් බලමු වැඩේ වෙන හැටි. How it happens now. Actually, light rays come in from the closer object up to මම හිතන්නේ step by step ඇන්දොත් හොඳයි පුතාලා. කලින් තිබ්බ diagram එක ඉක්මනට ඇඳ ගන්න. Early diagram. So this one. lens එක විතරක් දාන්න. ඊටු ටික මම අඳින්න කියලා දෙන්නම්. Now draw this. නැත්නම් පැටලෙනවා. So you have to concern these two light rays must be at the both ends of the lens. lens එකේ කෙළවරටම ගහ ගන්න දෙකලවරටම මැද්දට ගහන්න එපා දෙකලවට. So it must be use the full width of the length. Full width of the lens must be used. පුතාලා there are අඳින ගමන් අහගන්න there are two types of students in this world. One type is logical thinkers. එක වර්ගයක් තමයි තර්කානුකූල චින්තකයෝ. Logical thinkers. While others are crammers. අනිත් අය කටපාඩම් කරන අය. Okay? So crammers, they don't like this. They don't understand these types of theories, logical activities. So they usually went off. ඒගොල්ලෝ සාමාන්‍යයෙන් යනවා මේ වගේ එකක් පැහැදිලි කරත්. අපේ ස්ටුඩන්ට්ස්ලා දෙන්නෙක් දැන් මේ වෙනකොට අඩුයිලා තියෙනවා. Two students have gone. So they are crammers. Science is a logical subject. So logical thinking ability must be there. පුතේ එන්දනම් finish කියලා එවන්න. F දැම්මත් කමක් නැහැ. Okay, good. Amanta, do you have a microphone?
Yes, sir.
Puta, I don't remember your school. What's your school? Amanta. Maybe I know you another part of your name. Puta?
Amanta Gunawardhan.
Amanta Gunawardhan. Your school is?
Ranka Center.
Okay. So, Puta, look at this. I think already you have completed that. මෙන්න මේ පළවෙනි lens එක ගාවට එනකම් up to the first spectacle lens this light ray comes. දැන් අපි ඒක උඩින් ඇඳ ගමු. මෙන්න මෙහෙම. It comes like this. Good. මෙතන ලස්සන ස්ටෝරි එකක් තියෙනවා කතන්දරයක් මම ඒක පැහැදිලි කරන්නම්. Now, image is clear or not? Image is not clear. It is blurred image. Image is blurred. පොඳ වෙච්ච image එකක් ඇතිලා තියෙනවා. තිසන්‍ය මේ blurred image එක මොලේට තේරෙනවා බොඳයි. එතකොට එයානේ මෙතන ඉන්න boss. එයා එවනවා message එකක් කාටද එවන්නේ? Ciliary muscles වලට. මොනවද මිනිස්සුયો කරන්නේ? ඕකේ curvature එක වැඩි කරන්න. Increase the curvature. I cannot observe a clear image. දැන් මේ වෙනකොට ciliary muscles දත් හපාගෙන හරි හොද්දට ඇද්දගෙන ඉන්න දැන් මේ තව බෑ. ඉතින් ciliary muscles වලටත් හොඳටම කේන් තියනවා. එයා මොකද කරන්නේ? මේ පුළුවන් තරම් තමයි මම ඇදගෙන ඉන්නේ කියලා කියනවා. Then brain. Okay, ciliary muscles. I'll tell you good idea. මම මේ මනුස්සයාට කියන්නම් ඔප්ටිසියන් කෙනෙක් ගාවට ගිහිල්ලා සොලියුෂන් එකක් ගන්න කියලා. ඔන්න මොලේ දැනුම් දෙනවා පුජ්‍යලයට මේ තමුසෙට දැන් ඇස් පේන්නේ නැහැ උයි. හරි? ගිහිල්ලා ඔප්ටිසියන් කෙනෙක් හම්බෙලා වාට මේකට ලෙන්ස් එකක් ගන්න කියලා යවනවා. එතකොට වෙච්ච වැඩේ තමයි මේ තියෙන්නේ. He check and the inability of converging, therefore convex lens is used. Okay, new situation. Look at this. මෙයා චුට්ටක් converge කරලා දෙනවා. It converge like this. ඔන්න පොඩ්ඩක් හරවලා දීලා. Now, eye lens find it very easy to converge another thing. Okay, The rest of the thing can be easily converged by the islands. Islands එක දැන් මොකද කරන්නේ? ඔක්කොටම කලින් දෙයක් කියනවා. It tells to this helping spectacle converging lens to what? Thank you කියනවා. හරි? Thanks මම මේක කරගන්න බැරුව හිටියේ. ඔයා ඇවිල්ලා මට මේ වැඩේ කරලා දුන්නා. So thank you so much කියලා එයා එතකොට ටික converge කරගන්නවා. So that's the thing happening here. So you have to draw the arrows. Okay, that's the way. තේරුණාද? Can you understand? Neluka? Amanta? Okay.
Yes, sir.
Rama, what about you? Can you understand? Okay, good. එහෙනම් අපි diagram එක සම්පූර්ණ කරගමු. Okay, Rama. Good. I think you have completed the diagram. Okay. Now take down the solution by words. වචනෙන් ලියාගමු. Solution for the long-sightedness is wearing spectacles with convex lenses. This convex lens of the spectacle support to the islands to converge light rays කොහෙන් එනවද? Converge light rays coming from closer objects to the retina to focus image or focus it at the retina. Okay, I think you know the way of understanding this. Now, what are the reasons for that? Two reasons, as Nadika asked. Reasons. Weaknesses of ciliary muscles. Ciliary muscles වලින් මේ ඇද්ද ගන්න බෑ මේක. Okay, right? Weaknesses of the ciliary muscles. weaknesses of the ciliary muscles to increase the curvature of the eyelids. To increase the curvature of the eyelids. Weaknesses of the ciliary muscles to increase the curvature of the eyelids. Next reason. තව හේතුවක් තියෙනවා පුතා. මේ මෙහෙම වෙන්නේ මේ eyeball එක කෙටි වෙලා සමහරුන්ගේ. මේ eyeball එක මෙහෙමම තිබ්බනම් ගානට focus වෙනවා. සමහරගේ eyeball කෙටි. Okay, take down next reason. Short eyeballs. Short eyeballs. Okay, next we are going to study short-sightedness or short sight, myopia. Short sight, myopia. Okay, now I'm going to erase this. Take down the new topic, short-sightedness. Short-sightedness or short-sightedness, myopia. Short-sightedness or myopia. Now you know the way of understand the disease condition or the defect. පුතාලා ළඟ පෙනීම ආයෙනම් මොකද වෙන්නේ? ළඟ පේනවා. It cannot observe, he cannot observe, this patient cannot observe the objects far away. ඈත පේන්නේ. එහෙනම් ළඟ පේන එකක් ඇඳගමු. Okay? So this person can observe. Tisanya, please repeat the sentence. Sentence එක මතක නැහැනේ. Okay. නදීක සර් කාච දානවා කියන්නේ ඕකටද? කලින් නෑ පුතා කාච දානවා කියන්නේ මේ වගේම වැඩක් තමයි. Okay, the same thing. But that foldable lens is inserted into the gap between cornea and the lens. Cornea and the iris. මේ මැද්දට තමයි මේ lens එක දාන්නේ. පොඩි කට් එකක් දාලා roll කරලා ඇතුලේදී දිගා වෙනවා. So I'll explain that. පුතා කවුරු හරි last sentence එක පුළුවන් නම් මට නදීක type කරලා message එකක් විදිහට එවන්න. Okay, now look at this. Short sightedness.
Sir, last sentence එක කිව්වේ
මම අන්තිමට note එකකට දුන්න එකක් topic එකට කලින්. So I can't see far, but my glasses are convex, not concave. So I cannot see far. Shinal, බලමු මේ තත්ත්වේ. Can't see far. Then that means you belong to this short-sightedness. But my glasses are not convex. Okay, weakness of the ciliary muscles to increase the curvature of the eyelids. So second reason is short eyeballs. Okay, I put that. Tisanya, now you can take it down. Okay, thank you, Nadika. Chennai පුතා බලමු අපි වැඩි. Now you can understand it here. Okay. Short-sightedness. Okay. Relax ciliary muscles. He can clearly observe images closer. මේ බලන්න පුතා ළඟ තියෙනවා හොඳට පේනවා. Closer objects can be clearly observed. Closer objects can be clearly observed. That means closer objects are correctly focused to the retina. So this is the normal situation. Closer objects are clearly observed. But this is not the problem. Make a ප්‍රශ්නේ නෙමෙයිනේ පුතේ. ඒකින්ද අපි ආ broken line කරනවා. We make it broken line. So this is so logical, nothing to be cramped. පාඩම් කරන්න දෙයක් නෑ. Okay, next thing. But he cannot observe objects situated far away. මෙතෙන්ටම එන්න ඈත ඉඳන් එන parallel light rays අඳිමු. Now we are going to draw parallel beam of light that comes to the same point to make a logic. අපි logic එකක් create කරන්න යන්නේ. Parallel light, it's just like raising up like this. පුතා මෙයා මෙහෙම ඉස්සුවොත්, if this light ray is lifted up like that, what happens to this one? Converge more. Then it converges to this. As well as if we bring down this light ray, incident ray and refracted ray goes up. So they are interconnected, okay? So think like that. What happens now? Image occurs before the retina. හරි? අදාළ තැනට යන්න කලින් වැඩේ කල් තියා වෙලා. එහෙම වුණොත් ලෙඩක් නේ? නේ? So the specified location is there. ඒක බල බලා වැඩේ මෙතන වෙනවා. ලෙඩක් නේ? Sarah, those types of two diseases there. One is what? One is diarrhea. The other one is short-sightedness. මෙච්චර කාල දැනන් හිටියේ එහෙම ලෙඩ එකයි නේ. එහෙනම් අදාළ තැන පෙනි පෙනි මගදීම වැඩේ වෙනවා. So that's diarrhea. Okay, this one is short-sightedness. Okay, now draw this. I like all of you ask questions. I am ready to answer you. Tuhini, keeping silent these days. Metuli, Chetanjali, and all of you, if you ask questions, I like that. අහන්න දෙයක් නැහැ තේරෙනවද? Nothing to ask. Yes, finished. Good. Okay, now you know the defect parallel beams converge and image occurs before the retina. Retina එකට කලින් image එක හැදෙනවා. So that's the way. Next, let's solve this. Let's see the solution. So you have to draw a somewhat broad eye lens like this. And here's the short-sighted means that's clearly observed. The defect is object situated far away cannot be clearly observed. පුතාලා මේ ඩයග්‍රෑම් එක අඳිද්දි මේ ලයිට් රේස් දෙක කෙලවරට අඳින්න එපා. ඒ කියන්නේ මෙහෙම අඳින්න එපා. එහෙම ඇන්දොත් solution එක ඕගොල්ලන්ට අඳින්න බැරුව යනවා. Okay? So you find that difficulty. Therefore, draw it like this. And what happens? Image occurs here. Yes, the image. But this is the defect. We are going to draw the solution. Therefore, this defect rays are the template, and we keep that broken line. Okay, but actually, light rays are. So what we have to do now? Further converge, තවත් converge කරලා හරියන්නේ. It has to be diverged. පුතා මේ ඈත් කළා නම් හරි. For the diverging purpose, what's the type of lens we use? For the diverging purpose, what's the type of lens we used? මොකද පාවිච්චි කරන lens එක?
Concave.
Concave.
Concave
Very
lens.
good. So that's concave. Concave lens is used. මේක ටිකක් මැද චූටි දෙපැත්තේ බෝතලයක අඩියක් වගේ. Okay, so we have to use that. Okay, this is the way of that lens. Actually, light rays are coming towards the lens. No need to draw broken them because actually they are coming. Okay, from here onwards, what happens? It diverges. It diverges. Diverges like this. Okay, then this eye lens find it very easy to focus at the retina. It's easy to focus at the retina. Okay, write the solution. Okay, solution take down. Short-sightedness can be avoided. Short-sightedness can be avoided by wearing spectacles. By wearing spectacles with concave lenses. Good. Now draw this diagram. എന്തൊക്കെയാണ് diagram එක? These are not biconcave or biconvex earlier case. They are known as meniscus. Okay, meniscus, concave, meniscus, lens. Okay. I think you have taken down. Let's take down the note. Nadika is asking, sir, clear image එකක් form වෙන්න අනිවාර්යයෙන්ම iLens එකේ අගට light එක යන්න ඕනේද? iLens එකේ අගට. No, not need. So this is for our easiness. We draw this. iLens එකේ අගට යන්න අවශ්‍ය නැහැ. But it has to be focused to the retina. Retina එකට යන්න අවශ්‍ය. Good. ඔයාලට ඕන මේ මගින් මේක අඳින්න තිබ්බා මේ චුට්ටක් ඩයිවර්ජ් වෙලා. හරි? ඒක වලටම යන්න අවශ්‍ය නැහැ. Okay, next take down. Reasons for the short-sightedness. Reasons for the short-sightedness. Inability of decreasing the curvature of the eye lens. Inability of decreasing the curvature of the eye lens as required. Okay, next one. Look at this. If the eyeball is somewhat shortened like this, ඇත්තට මේ වගේ ඇඳට මේ මෙච්චර මගට වෙන්නේ හුඟක් මෙහාකට තමයි වෙන්නේ. So reason behind that is elongated eyeballs. So large eyeballs. Okay. So take down another reason. Existence of a large eyeball. Existence of a large eyeball. No matter you can tell. Long eyeball. දිග eyeball එකක්. Yes. You learn these things very clearly and logically. ඔයාලා logically මේක ඉගෙන ගත්තා. Okay, so now I'm going to stop the class here. So we were here for around 2 hours, 7:30 to 9:30. What do you think? තේරුණාද? Could you understand things I explained?
Yes, sir.
පැය දෙකක් නම් දිල්ෂාන් යනවා
Yes, sir.
දැනුන්නේ නේද? අපි වැඩ කළා. Okay, so let's stop here. Have a nice night. Goodbye, all of you. තෙරුවන් සරණයි.
Goodbye, sir. Have a
Thank you,
nice
sir.
day.
Goodbye, sir.
Good
Bye,
night.
sir.
Bye.
Thank you,
Bye, sir.
sir.